Okay, so while I'm setting up here, gotta make the tweets and do the self-production, yada yada yada. Can you tell I just woke up? Oh wait, give me a second, gotta BRB for a bit. Okay, let's see. Doing the usual. Okay, that's done. Time to make a tweet about this. Even after all this time, I still struggle to remember my hashtags. Hello, David Jones. Give me a second to finish this up. Was this really all I wrote last time I did this? Damn, I was looking back at, I was looking back at everything, or everything that I wrote. So, it appears that, I have found, or while I was working with some people, that I've found some solutions to some of my problems, but Um, not everything. Hello, Oats. Let's switch over to this. So, last time we, were talking about this, my dad wants me to build an automatic plant waterer. We gotta water multiple orchids, it has to run automatically, and he gave me some pumps to use. So, I don't, I think, for this, we're gonna have to, so let's start with each, thing. Internet connectivity. We don't need it. Because, what is that? Ugly asphalt. No. We gotta, where is it? There you go. We don't need to be bold either. We'll bold it. Why not? We do not need internet oh, come on. We do not need internet connectivity. This can run open loop. How do we water the orchids? Exactly over here. Yeah, I think last time we went through our basic problem. We broke it down into each individual problem. And then we just discussed all that. Now I think we're gonna get into the nitty-gritty details. So as always, whenever you have a problem, you either A, ask a friend who's done it before, or B, go on Google to look up a solution that's already been done. And one of my friends has made a watering plant where, let's see, let me draw it out. So let's say, come on. Let's say this is like the pump, right? Here's the out. And then here's the pipe. And then he stuck a pipe onto it. Oh, whoops. I can't draw with the mouse. Something like that. And he plugged the end. And then he poked holes into it. So that when the pump ran, it would shoot out water through those holes. I'm thinking to myself, I mean, for our purposes, because we're not changing things around too much, this is a very viable option. Instead of, directing water from one pump to each plant. And controlling how much, controlling the water flow for each individual plant. I mean, this works. The problem now is finding dimensions, but that I just need a calipper for that. Indoors or outdoors? It's gonna be outdoors. So I'm thinking of ways to make it more applicable for outdoors. The wire connecting the pump, or the wire for the pump, is pretty rugged, but it's not very long. I mean, I could fix that with a bunch of electrical tape, but yeah, so let's see. Now we have to get into more logistical problems. So when we use the pump, we need external drivers. I actually found external drivers. Let me see if I can buy them on Amazon real quick. Amazon time. You know what? Let's add. Where is it? Let's see. I remember my friend was using a 5-volt relay. Um, let's see. Yeah, it looks something like that. So if you don't know what a relay is, it's basically a switch, right? If you connect it, let me look up a picture. Come on. Well, I guess most of them now look something like this. Ah, whoops. Come on. Oh, did it erase everything? Oh, it did not. Relays look like this. Right? Or at least that's one type of relay. Where it's like on the other side you can see pins. Oh wait, I forgot that I don't have background music on. Boom. Um yeah, so these are switches, right? How do I So you have an input going. Oh no, I'm not gonna use that. I'm gonna use green as an input. You have an input going in. Uh, a lot of times they act as. There are many different types of relays, as there are different types of switches. But what I need is something that acts like a push button. Something like that. Oh, whoops. Right? So when this activates, when I activate this relay, these the button pushes down and it connects the two things together. When I'm thinking of relays though, I'm thinking of like what's it? Something mechanical. Uh-oh, this is an even higher res picture. It's not the most high res thing out there. Yeah. So in a relay like this, there's an actual like magnet and stuff pushing the switch whenever electricity flows in. So I could use one of those, but they're kind of they make a very loud click. And because it's physical, there's actually I don't know if these are physical either, but with something like this, it's probably more what's it? What's the word? It's more likely to be susceptible to wear and tear because we're dealing with moving parts. I don't know if this one has any moving parts, but the main reason why I'm using this versus that is that this one's easy to use and I can plug an Arduino to it. Stupid easy. I'm gonna look on Amazon right now. They sell boards with like protection and stuff too. Let's see. One channel relay module. Do I really need 10 of these? But it's cheaper if I get 10. Let's see. I'm probably going to go with cheap boards from Amazon because they're cheap. Yeah, I'll add this to my cart. I also now need, Arduinos. So, I've solved this problem. Oops. I've solved this problem. Watering the orchids, I haven't solved that problem. We've solved this problem too because we don't need connectivity to the internet and I want to get this out as fast as possible. So, Arduino it is. They're also relatively cheap. Let's look up how much they are on Amazon. Yikes. They were not as cheap as I expected, but they are knockoffs. The nice thing about Arduinos is that even though the real thing is really expensive, knockoffs are much, much cheaper. The real Arduino Nano is like $25. But you can get a knockoff. Without the pins or cable for 17. Alright, so I'm adding this to my cart too. The reason why I'm using Arduino Nanos is that they're tiny. Let me look this up. They look a little something like... Oh, that's PNG. See, copy image. Looks a little something like this. They're tiny. That's I forgot what type of USB that is, but it's slightly bigger than those USB. I think it was like USB A or something like that. I don't know. I don't remember. You can plug them in very easily and program that way. Stupid easy. Raspberry Pi, there's a little more that goes into programming it, and I'm not entirely sure how that works, so I'm not going to use that. Oh, I should probably... make that black. Alright, this over here. It's outdoors, so... Another problem that popped up was that, okay, we have an Arduino and we have those pumps, right? The pumps run off of 12 volts. So I just need some protection for the circuits. Yeah. So my idea was to just toss the pump into a bucket outside because the pump is designed for that, hopefully. Let's go to... So if we have this idea, we have bucket. Oh wait, no, never mind. We have pump inside bucket. We have. Can I? We have wire coming out from here, going. Let's see. Pretend that this is a door. Going underneath the door. Right? This is outside now. This is outside. Go underneath the door. And going to a 3D printed box. Where that is connected to our relays. I'm gonna use green for the board. A relay board. And that's connected to the Arduino Nano. And on the I'm going to connect this to some sort of power. Some sort of wall outlet. Yes, we do need some protection from the circuits, but if I have all the electronics inside, things will be made a lot easier. And there's plenty of outlets near the wall. Here's another issue. The pumps use 12 volts. The Arduino uses 5. Fortunately, there is a part that solves that issue. It is called a buck converter. So, buck converters, right? They take a voltage and they convert it into another voltage. Or rather, they take a DC voltage and convert it into another DC voltage. Unlike a transformer, which converts an AC voltage into another AC voltage. But we're not dealing with AC here. So we don't have to worry about that. Buck converters, I'll write that down in a little bit. But buck converters look a little something like this. Okay. I'm gonna make a new tab down here. I'm gonna call it logistics. So yeah, we have a basic design right here. So now we need to figure some stuff out. Oh, right there. I think that was 24. Looks about right. Thing is, I know, I have a 3D printer and I have very preliminary CAD knowledge. So it's not going to be extremely difficult for me to design my own box. I think it was at 14. Yeah. No. 16. So. Whoops. But first, you need to get a DC voltage in the first place. So are we getting 12 and down volting to 5, or the other way around? I'm getting a 12 volt supply and bucking it down to 5. Because we have a lot of 12 volt. Apparently, we have a lot of 12 volt supplies laying around. So, powering system. I also want to be able to control when this thing is turned on. So to be honest, I don't have a good solution for this, but or I don't have a final solution for this, or like, let's see. But I could come up with two solutions I could think of, and I don't know how good they are compared to each other. I'm gonna have to do an analysis later. So, solution number one is a barrel jack. This just means that it's easy to plug it in and unplug it from this. It's a lot easier to plug it in and unplug it from, you know, the electronics box than it is to unplug the actual power supply. Option number two, implementing a switch. That is more of a pain in the ass. So I don't want to go with that one. But those are two options that I have. Let's see. Other logistics that I have to think about. Well, whatever I don't think about now. Oh, whoops. Whatever I don't think about now, I'm going to have to think about anyways when making it. See, I don't have all the parts on me right now, so I can't go ahead and jump into designing the box. But another thing I could do is steal a design online and use that box. So I'm gonna go on Thingiverse right now. And to see if there are any boxes that fit spec. You know, I was actually looking at boxes earlier because I bought some really thin saws, right? For like Gundams and stuff. And so I wanted to be able to toss them in my mini toolbox without them getting bent and stuff. So I was looking around like resealable boxes. First thing I'm thinking of is the ultimate box maker. I mean, these look rugged enough, but I don't want to have to make my own box. Let's see. What I could do is take one of the boxes I found and then just scale it up. Actually, that's probably what I'll do, because tolerances on... I printed one of them, and tolerances are really tight. So I really could just scale up a box by maybe, I don't know, 2. I can just double the volume of this. So that works. The problem then would be fitting everything inside the box instead of designing the box to be able to fit everything. But I don't think that'll be that big of an issue. Another issue might be will be boring a hole inside the box. But I can get through that with a drill. it would be nicer if I could poke a hole in via CAD, and I could, but that'll just make things harder to what's it? That'll make things, I would have to fit the power supply in there, or the barrel jack in there, or whatever I'm using, with where the hole is, rather than just make a hole where I need one. The thing is, the box is going to be inside anyways, so thank you. Let's see. So, oh yeah. Yeah, the cable might be too short. Or the pump wire might be too short. So, and we need it to be outside proof. So, best idea I can think of now is, yeah, so we can probably buy like really thick wire that has like 2 wires inside of it already. So, and we could seal it up with some heat shrink tube. So what that is, if you don't know, it's like a rubbery like sleeve that you can cut and put over wires. That when you heat it up, it shrinks so that it fits like snugly over any electrical connections you make, to protect it from, like, you know, stuff. So now that I have this, I don't know the details of how to power a an Arduino with an external power supply. I don't know the logistics of that. Let me Google this real quick. External power supply. Using USB port, using a V-in pin. Your input voltage must not exceed the safe limit of Arduino Nano, that is 12 volts, and the minimum voltage for V-in is 7 volts. So we could use a 12-volt power supply, but I don't want to risk it. So we're probably gonna have to step down to like 9 volts anyways. You can tell this is an engineering stream because I have an energy drink right in front of me. Not sponsored, by the way. Damn, this is really sweet. What the hell? Jesus Christ. 36 grams of added sugars. That is not healthy for me. Let's see. Yeah, so it looks like you can power it 3 ways. 1, through the V-in pin. 2, via USB cable, which I'm going to use to power it. Engineers are that and racking up technical debt through the entire process. Yeah, I'm going to figure out the logistics later. What do you mean by technical debt? Just, like, actual monetary debt? Yeah, because what I don't have to design myself, I won't. And the problem with buying these breakout boards is that you can never buy only one. See, I'm buying 10 of these now, and it runs me like $16. Sure, I have 10 now, and next time I need one, I don't have to buy it, but... I now have 10. I don't need 10 right now. Jesus Christ, the parts count is coming out to $45. For 10, for putting off more elegant them later. You'll have the engineering and well. Yeah. There's probably a more elegant solution to this. But man, I just want to get this thing done because I've been putting it off for 6 months. Literally 6 months. Holy shit. Last time I did it was in what? June? Something like that. Let's see, is there... I don't know how good the wall adapter is. That's why I'm using the buck converter. Theoretically, you could... I looked it up. You could connect the Arduino Nano to 12 volt or to 12 volts. But in the event that it isn't, I don't want to be there. I don't want to be there for that. So I'm gonna step down to 9 volts instead. I don't think electromagnetic interference is going to be a big concern here. Mainly because these smaller ones I think they use They mentioned Opta separated, but I think that's just the circuit. That the output circuit is not electrically connected to the input circuit. And I think everything in here should be shielded. If it isn't, it shouldn't be. I don't think it'll be that big of a concern. I wish I can get into programming, but I do not have all the materials yet. At this point, what I would do is toss something together, test each of the parts to see if they work. If it had the parts, I would, you know, hook up an LED to the Arduino and say, "Hey, it blinks," or be like, or measure the. I have a power supply, so I could just measure, or adjust the buck converter to what I need it to. Unfortunately, I have neither of those right now. And I don't know, I really don't know if I'll need the relays down the line. Maybe the buck converters, because, well, I mean, if I'm using the buck converters, I will be using relays as well. Most likely. $45, not exactly down the drain. Let's see, anything else? I should set up a throne so that you guys can buy me stuff. Because that would be funny. I think. Because I was thinking after yesterday, it would be really, I think it would be a lot funnier if you can actually hear me fail in real time on Rocksmith. But yeah. Actually, let me look at this relay board again. What's the max rated voltage on the other end? 10 amps at 250 volts AC. That's perfect. We don't even need AC voltage, or we don't need the AC voltage, but DC, just AC, but going one way. All right. I think I could just buy barrel jacks at the local electronic shop. But oh wait, I have Amazon Prime. That means this comes tomorrow. I should have bought these yesterday. Well then. And that's that. $50 worth of parts, of which I'm only gonna use like a fraction, like a 6 or something. Damn. I think it would be funny at this point to mess around with the Arduino and just, you know, make some neat stuff with some sensors I have around. Do I have any sensors around? I have a microphone. But that's about it. only been streaming for, I don't know, oh Jesus Christ, an hour. I'll use the rest eventually in my future projects. Let's see. I had a list of, you know, during the summer I was gonna have like a gauntlet, a poll for which engineering project should I make? What is it? Where is it? Aha, there you go. I came up with a bunch of really shitty ideas that could be really easy for a summer project. Or easy-ish. Okay, I really don't remember the purpose of one of them. Okay. So here's some of the really, really dumb ideas I have. So I've never been really good with smiling in photos, right? I hate smiling in photos. So I was gonna build a robot or some sort of thing that helps me. They kind of helped with that. So what it would do is spritz water in my face whenever I didn't smile. That has to do a lot of computer vision stuff, which I am not very good with. So that's more of a programming issue than it is an electrical issue. Ooh, I like this one. You could probably tell by the time I started this stream, but I am not a morning person. I don't like waking up. In fact, I like sleeping. I like sleeping a lot. Or I like sleeping a lot. So, an alarm clock isn't good enough. Right? And I've noticed that the most effective thing when I wake up is not the sound of the alarm, but my phone vibrating next to me, because I sleep with my phone right next to my head. Probably not the most healthy thing, but that's what it is. So, what if I attached a very, very, very strong vibrating magnet, or like vibrating actuator or something? Perhaps even a solenoid in my pillow, so that it vibrates whenever I wake up or whenever my alarm goes off. It's genius. And the nice thing is, I can integrate this and make an alarm app. So if I do that, it teaches me two things. One, it reinforces, you know, my electrical skills. Number two, it'll teach me how to make like Android apps, and I can just, you know, buy a cheap Android phone. How much do they go for, anyways? Oh, sick! I can get a smartphone for 30 bucks. Like one of those prepaid smartphones. What do they mean by locked, though? I could probably just take out the SIM card. That would hurt if you accidentally fall on the part of the pillow, the vibrating bit. No, it will just hurt, period, if I'm using a solenoid. Because Solenoid, the only reason why I suggested Solenoid, because Solenoid, funny. Okay, when I made this idea, it was in the context of coming out of COVID, and me not having interacted with my classmates a lot. So at that time, I was thinking, man, actually, you know what? It still applies now. Like when I was little, I wasn't the most sociable person, right? And when I would look at all the movies and stuff, shows and TV, I would see, you know, kids playing paper football with each other. So what if I made a robot that plays paper football with me? I could make my own friends. So I would have, like, I don't know, a goal, and it would detect a paper football would go across the goal. It would tell me when it's my turn. It would shoot the ball. Biggest issue with that is I don't know how it would know if it won or not. Just make two of them and force them to endlessly play paper football with each other. That would be funny. But it also conjures kind of an existential kind of crisis, because now I've made two robots that have no purpose other than to play paper football with them until the end of time. And I don't want to deal with that existential crisis. I don't want to deal with that philosophical issue. So yeah. This is less of a problem. Next idea. This is less of a problem now that I have like a giant cup of water next to me at all times. Or rather two. I have one at my desk. I have one giant cup of water at my desk, and I have a giant cup of water right where I'm on my nightstand, because sometimes in the middle of the night I'm all like, damn, I need to drink water. What if I make a coaster with like some sort of pressure sensor on it, right? That would count the amount of time from, you know, when I drink water, right? So that whenever I reach the end of the day without drinking all of the water, it would, like, you know, vibrate or something, annoy me somehow. Like, I don't know, I could attach the same solenoid that I was gonna put in my pillow and just have it destroy my fucking desk. That'd be a funny idea, I think. Because, you know, staying hydrated is very important. I say as I'm sipping on a energy drink. I should be drinking water. There's a lot of stuff on my desk. I don't remember. I think this is just one of those it would be funny ideas. But leaf I was thinking of, you know, just leaf blowers, right? And how, you know, they move leaves by pushing them around. Well, what if I wanted to, you know, collect the leaves and have a leaf sucker instead? I don't remember why I came up with this idea. I just now it's a bad. Now that I think about it, it's probably not the best idea out of this. But it would be funny if instead of, you know, blowing the leaves, it would suck up the leaves. So a vacuum. Anyways, next idea. This also has to do with something when I was little. I don't know about you guys, but when I was little, I always had the primal urge to just take one of those Ritz crackers and just fling them across the room like a frisbee because it looked like one. It was a flat circle. It was a disc. So, and you've seen those Nerf guns, right? That have like that launch discs. Hold up, let me pull up a picture. Yeah, there you go. Not sponsored, by the way. Something that looks like this, right? Where it's got those discs lined up like that. They look just like Ritz crackers. They look just a stack of Ritz crackers. So what if I made a gun that shot Ritz crackers like frisbees? I think that would be that would be funny. Oh my god. Hold up. Screw that. Screw this. Screw this thing. See one of these. Imagine a 6-barreled Ritz cracker gun. Now, I don't know how to deliver force to it, or enough force to it that it would fly, or if it would even fly, because I never followed through with those, what's the word? It was something thought. I never followed through with those intrusive thoughts. The Ritz revolver. That is a great name. I'm gonna keep that. Thank you, Oates, for that idea. I think, okay, this next idea, it's kind of on the electro boom side of stuff. So, see, not that I have I'm sure it wouldn't turn into a rich shotgun instead. Yeah, I need a mechanic. I need to enlist the help of a mechanical engineer for that. But my next idea, see, I don't have an issue with this. Not very often. But, I know a lot of people have issues with getting salty in games. Right? When I get personally, I don't get very salty in games. I don't think you've seen me get angry at a video game before, right? Definitely not Toho. But I've seen it be very common in a lot of esports players. So in my mind, I'm thinking, why don't we fight fire with fire and have a robot that when it detects rage, it kicks me in the shins so that I stop yelling. The reason why kicking me in the shins was an option was because there's a lot of space under your desk. On top of your desk, there's not so much space, but underneath your desk, there's a lot of free real estate. So I don't know how it would do that. Maybe with a blood pressure or heart rate detector or heart rate sensor, and what's it? And a microphone. And I haven't thought of a way to, make it kick me in the shins. But, it's just an idea. These are all my ideas. Please do not steal them. Alright, this last one. Or, no. This last one, I am eventually going to follow through with it. I have no idea when, but I am going to follow through with this one. Mainly because I basically have everything bought. Fight out of her. And right into the room. Yeah. Speaking of video games and interfacing with real life, I was watching Maxor's Ultra Kill video. Do not watch if you have epilepsy. And I was reminded of the Ultra Kill how do I say this? The Ultra Kill external pleasure peripheral mod. Ultra Kill Rumble support. There you go. And the fact that exists, it's like, this is why I became an engineer. To do the funny like that. It does have Rumble support. You need context. There is no context. Ultra Kill Sex mod. Anyways, the video game that has Rumble support. Yes, it does. I'm not allowed to give context because YouTube clear the service. If you Google it, it should be the first tweet you see. Stuff like that is why I became to make stuff like that is why I became an engineer. Anyways, back to my last idea. So, I recently bought one of those. By recently, I mean like a year ago. I bought one of those Star Wars Force sensors, right? It was like an EEG. It was like a machine. It was like a sensor that detects your brain waves and stuff, right? Hold on, let me. It's a toy. If you ever heard of Mindflex, it's basically the same thing. Yeah, it's basically one of those Mindflex doohickeys. I remember wanting those a lot as a kid. But it's like I remember thinking as a kid, it's like it's very expensive, I'm only going to use it twice. So like I never ended up asking my parents for one. Anyways, so it's like Mindflex. I have one of those things, right? And it detects brain waves. So I know there's probably a certain brainwave associated with stress, right? And so what? And I also know that an Arduino can act as like a keyboard. There's a library that allows it to interface with the computer like, you know, a keyboard. So what if, right? Let's say I'm on the internet, right? Or rather, I'm streaming. And, you know, let's say I'm streaming Rocksmith like yesterday, right? And then and then a song shows up that suddenly has the N-word in it. And so I panic. And then the Arduino knows that I panicked through the EEG. And it alt tabs out of the game. Now, I'm probably going to use it for more, I'm probably going to use it for a different reason other than, you know, just alt-tabbing out of the game that has an N-word. I'm going to use it to alt-tab out of scary games as well. Because I do not like horror. If I get jump scared, nope. Just close the game. Or like when I'm coming up with these really, really bad ideas and somebody comes in the room to shut me down, I can just, or shut these ideas down, I can just alt-tab and be like, oh, I don't know, no, nope, I didn't come up with these shitty ideas. The automatic alt-tabber. I don't know why I haven't gone back to it yet, probably because I haven't found a way. Oh yeah, I did try it at one point. I couldn't find a good way to interface with the device. So it just gave me noise. So I'm all like, I'll get back to it later. A year later and I still haven't gotten back to it. Whoops. And I bought it for like 20 bucks, so. How much is an EEG kit anyways? I saw one that looked like it was made out of 3D printed parts. Oh boy, all-in-one EEG electro cap starter kit. $2,800. Damn. $19 channel EEG headband, no cables. $50. Heavy signal processing. Here's the thing. There is a library that does all the signal processing for us. There's a chip that does all the signal processing for us, and it gives you all the waves that it detects. So I don't think it'll be too hard to implement. I could probably do it over the summer or over winter if I wanted to, but my excuse is that I am tired every day and I don't want to go back to it. There is really no good excuse for me to. There really is no good excuse for me not to do it. yeah, I'll probably just get started on it 2 weeks from now. The reason why I'm not doing it next week is because I am on a trip, vacation. Yes. So not next week. That's also why I won't be streaming next week, because vacation. So yeah, I think I did some good work here. Yeah, that looks about right. I was going to make a wiring diagram of all this, but I don't have all the parts yet. So let me paste this in my personal clipboard. Let's see. I did find some. There was a game I really liked. Or I bought recently. It has to do with engineering. From my understanding, or from what you said before, you seem like a programmer. That leads me to believe that you are that you've done a little bit of a digital logic before. Is it a Zachtronics game? No. But it's very similar. I was talking to one of my engineer friends about it. He basically described it as what's LabVIEW, as the basically LabVIEW's HDL. Let me that's not what I meant to do. Let me disable this. Let's cut to here. Disable that. And you're probably gonna cringe at some of my solutions, but that's whatever. It ain't even that bad. Why is it not oh, that's why it's not capturing. It ain't even that bad. Let's transition here. Welcome to Turing Complete. I've completed half of it already. It is kind of terrifying in the fact that, yeah, I'm halfway through. It's all digital logic. So you start with connecting an input to an output. Then you go on to figure out what a NAND gate does. And then you build. And this is a AND gate. This is an OR gate, I think. No, this is a NOR gate. And this is an OR gate. And so now you get access to those gates. Going through that, I have made a basic ALU. And then now through here, this is an adder subtractor plus ALU. The thing is though, this is built off of the other design. Oh wait, the game might be a little loud. Let me turn that down a little. What was I gonna say? Apparently, what you build here determines the shape of, you know, your ALU. Determines the shape of your components down the line. Which I think is really interesting, but at the same time also very terrifying. Because then I'm gonna have to deal with ALUs that look like this. And that's not efficient at all. It doesn't look nice at all. I kind of just brute forced it. Or at least this section I just brute forced. I know there is a more elegant solution because one of my friends, one of my friends that introduced me to this game, had a way more elegant solution. But you know what? This is my design. Simulate some you need as a part of later component. Yep. Astral turn. The message from now on to save between levels. Okay. Copy a source from a destination. Instruction buttons level determines the source. Source and destination can be one of 6 registers. We'll name them. There's a dedicated input component, which can be a source and an output component. Wait a second, this is just an I/O pin. Click the instruction icon in the upper left corner. Ooh. I actually have no idea what I'm supposed to do. Oh no, I don't want to review the solution. One factory. Copy from. Oh! Copy from input. Put to output. Oh boy. This is a lot. Taken. That's input. That's output. And that's the instruction. Oh boy. There is probably an easy way to. There is probably a really elegant way to do this. Unfortunately, I am not an elegant program. I'm not an elegant programmer. So these first 2-bit. So these last 2 bits are unused. It's only these 3 bits that matter. I do have a 3-bit decoder. And I can use 2 of them. That's one set of instructions. Oh, that's not a good idea. Should probably just out one. Oh yeah, did I mention that this game could output these as Verilog? Or can output your circuits as Verilog? So yes, I could take this and slap it onto an FPGA. If you don't know what that is, it's a chip that has a bunch of gates on it, and you can configure them with a hardware description language like this or Verilog. Okay. Okay, so this is my source, this is my destination. I should probably name these. Okay, never mind, I can't name them. So first, I'm going to have to... And I'm going to keep moving all over the place. You can just buy Turing Complete and then export it as Verilog. It's genius. And best thing yet, Turing Complete is 20 bucks. Unlike Verilog. Or not Verilog. Unlike LabVIEW, which is a subscription. I've actually never used a LabVIEW HDL before. So. Okay, so. Save. Okay, so what you want is... When this turns on, we want the thing at each specific thing to load. And then we have an input and an output. We want, do we need an input register? Should we have an input and output register? Do we need one? There is probably, I don't know if that is the elegant approach, but it is, it is the approach that I would use. um, all right, this is the destination. Hmm. So I'm gonna call this top one 0, 1, 2, 3, 4, and 5. Input, output. Also, LabVIEW doesn't have synthwave music. We want... Also, if I beat this game and get at least to right here, I can say that I designed my own Turing-complete computer. I can put that on my resume. Hey, it works. Oh, what the hell? Let's... give me a sec. I am going to use the restroom. Okay, I have returned. Well, it's not really a tutorial. It's more like, here are some assignments, figure the rest of the shit out. I wouldn't call it a tutorial. It's more of like it's guidance. It's not a tutorial. What the hell's going on? Oh wait, this is the input. Yeah, so this is the save. Uh Are those bits JK flip flops or T flip flops? I can't tell. Which bits? These are all registers. The only flip flops we have access to are D flip flops. The quote 1-bit memory is a D latch. Wait a second. 1, 2, 3, 4, 5, 6, 7, 8. Huh? Wait a second. That's 1. That's 2. That's 3. That's 4. 5. That's output. Four, 5. What's input? They give you an instruction set, but I completely forgot it. Oh wait, this one's input. Okay. I'm more like, because earlier I'm more like, I'm tripping. Because, um, because I know 7 isn't used in each of those. Alright, so I need these to activate those. Okay, so what I'm doing is, um, the command activates those, activates each of these inputs, or activates each of these. Now, I haven't designed, what goes where, or how to influence, how to make each thing go, yeah, how to make each register go where I need it to, or have the data go where I need it to. Haven't designed that yet, but I will design that in the near future. Move that over there. Yeah, so what I need to do is get this. It's like this command, these first 3 bits tell me where to get the data from. These 3 bits tell me where the data should go. No, where the data comes from, where the data should go. And yeah. So this goes in here always. And I think these should be always, this should be always loading, or this should be always saving. Oh wait, I hooked these up wrong. These should be switched. So that tells it to load. This should be always saving. Well, both input and output should always be saving. This tells it what it outputs. No, this is the... Is it Destiny? Oh, wrong thing. Input. So if I want something to input, that means I want it to save. Or that means I want it to load. That's the load button. Yeah, I have these hooked wrong. Whoops. Whoops. Okay, so I'll hook these up first. Oh, whoops. And that... Okay, so let's say we want ah let's say we want let's see. We want to copy input to output. So let's copy input to output. There you go. And because whenever the input is used, let's connect this pin to the enable. We're decoding destination to the register's E pin and a source to an AND array along the register. Let me process what you just said. Let me process what you just said first. Okay, so decoding the destination to the register's E pin. Enable pin. Yeah, and the source to an AND array along with the register's output. To a data wire that goes to the register's D pin. Yeah, something like that. I was thinking of using muxes instead of not muxes. I don't think we need an AND array for that. We could just use switches instead. So, because these are the outputs, ooh, so we have both input switches and output switches. I think that'll work. These are controlled by the... Let's see, if we want this to output, these are controlled by the input switches. These are controlled by the... These are controlled by the output. If I'm understanding this correctly. Oh, come on. There goes my phone. Not a mux, but a tri-state. Basically a tri-state buffer. I'm gonna be real with you, when I first heard of that term, I immediately thought of Phineas and Ferb. With the whole tri-state area. And so we connect all of these switches together. We connect all of the outputs together. Connect all of these Connect all of these inputs to here. We connect all of these out here. We connect these. By the way, blue is bytes. Orange is bits. So if we want this to output, that means this is the input. So that means I have to connect it to... I have to connect to these. This is the... That's the load, yes. Yeah, so I can go back and use switches and muxes for my ALU. But I'm lazy. Byte transfer is parallel. Uh... Hmm. I'm gonna have to get back to you on that one. I honestly... Maybe if I drink more caffeine, I'll understand. Oh wait, yeah, byte transfer is parallel. It you can think of it as either parallel or really fast serial. Alright, let's see if this works. Copy input to output. Oh wait. Okay, so I need to turn off... Wait. I need to turn this off. Turn off the saving. Turn off the fact that it saves. Let's see. Copy. Let's see. Copy this game. Oh, I should not have put that there. Actually, it worked out. Does this work? Do I even need this register? What if I just hook this up to the switch? Third tries a charm. Let's go. Okay, let's read that again. The circuit you build in registers can copy values between registers, while the arithmetic engine can do different operations on two inputs, but you need to be able to do both on the same circuit. To do this, decoder, which motor computer, 2 bits we haven't used yet. So I'm gonna use the mux. I'm going to be using the what was I gonna say? The mux implementation here instead of using the AND array, because I need practice with that. Let's see. Instructions, the 2 highest bits we use to determine which mode we are in as follows. Here, that means any value. Or don't care. Then send. Do the correct output. Immediate. Okay, so this is immediate. That's immediate. Oh wait, I just need switches. Let's see. So first I'm gonna have to turn this into bytes. And then I can use 2 muxes. Or decoder. I can use a decoder and some AND gates. But why use the decoders when I can just use an AND array? Wait, I can just use a 3-bit decoder and just... Oh wait, wrong bit. I attached it to the wrong bits. I move this. Let me move this down here. I literally have a part that does that for me. The calculation server was... What does immediate mean? The copy and calculate mode. Don't forget the decoder has a disable. You only have to worry about the copy and calculate mode. This pin always emits the value of the register regardless of load is selected or not. Okay, always output, got it. Alright, so first I gotta clean up these switches. Whoops. Let's move this switch over. Whoops. Let's move this switch over here. Just making things a little bit tidier. There you go. But now I have to deal with those. Let me take all of this and scooch it over a little. Good enough. Oh, that's not what I meant to do. Wait, let's go to the component factory. I want to go back to the decoder. I want to make the footprint smaller in our decoder. What if I did that instead and just oh, now it looks like that. I mean, it's funky, but at least it works. Okay, so I don't need those two. I can just keep this here. Connect that there. Oh wait, so I don't have to concern myself with calculating yet. I just need... What does immediate... Oh, immediate just means... Is it copying an embedded value? Instead of... Immediate mode is basically copying an embedded value, such as from the program instruction itself. Instead of a separate input. Putting it in a register. No, that popped up right when I was about to start implementing it. So that was perfect timing. Thank you. Copying an embed. Copying an... Okay, when I calculate, save the result in reg 3. So basically, we should only do this stuff if what I'm hearing is we should only do... Oh yeah, let me keep that again. We should only do this stuff if copy is on. That's what I'm hearing. So, what if I just add a switch in front there? All you need to do is add a switch. A bit of a tight fit, but it works. Wiring's gonna get a little messy, but it'll be okay. And then calculate. I have an ALU. I forget. Okay. So I'll put the ALU right here. Uh-oh. I need to make my ALU smaller. Okay, so take this. Oh wait, no, that's instruction. Whoops. Move that up. Input 1. Input 2. Ooh, that works perfectly. So in this mode, we need both register. We need to load. Oh wait, I need to move this out one so there's space for the future instruction. So if I need to calculate, that means I only need to save at 3. So okay, so this is output. Yeah, these are saved, so I need that to go here, which is connected to this bus, or that line right there. So 1, 2, 3. Short circuit. Output ALU. Switch. Maybe I need to add a switch here too. Oh boy. Actually. And have this be controlled by the enable pin right here. Short circuit inside the decoder. I only need it. Let's see. Why not use an OR gate? Yeah, that's what I'm thinking. That's exactly what I'm thinking right now. So I'm just thinking about where to place it. I'll probably put it in here then. Will it fit? I want to turn it that way. Perfect. Have this go through here. Oh, whoops. Oh, god damn it. Well then. Okay, so I gotta move this down here instead. Um where Oh wait, I put that one apart for a reason. Okay, so oh, I can just I got skill issued so hard. I forgot what I did to prevent that short circuit. Oh, I get what's going on. What I need isn't a switch, but just a complete turn off. But all I have to do is just add a switch to here. My solution to everything is a switch. Probably not the best solution, but it is a solution. And having a solution is better than having none. Oh, whoops. Uh-oh. Why can't I just move this? Move this down one. You can connect a... Yeah, no, we can't go that low level. Okay, it's connected to this. Okay, let's see if this works. What does it mean by calculate? Ah. Where does 255 come from? Maybe I don't need the switch. Why does register 3 need to have the value 255? Alright, maybe I'm gonna have to come back to the ALU. Oh, whoops. Oh! Oh, god damn it. So I really did need that switch. Well then. Okay, I think I know what I'm supposed to do. Disconnected that one. Well, that turns on. I need another switch here. I can move the switch wherever I want, but this goes all the way down here. Very nice placement by me if I don't say so myself. Let's see. This all is only activated when I have calculate on. Oh wait, no, this is copy. This one's calculate. Okay, calculate is no. Yeah, calculate is actually calculate is this one. Yeah. It works. Right here is a little messy, but it works. Oh my god. For a little extra neatness, I could probably do this instead. And it doesn't look like absolute shit. Instruction input component has been removed. As replaced by a program component. Every tick uses a counter to load the next instruction in the program. Oh! Oh! Oh no! Well then! I have a 1-bit counter somewhere. We're loading actual code now. Oh no! I think I'm stopping now. Let me make some wires coming out here. I know these are dangling, but well, good thing I made it super spacious. Oh no. I think I'll continue this some other time. It's literally just wait, how do I export it as... I don't want to view solution. Manual, switch schematic. Oh, what? Yo. But how do I export to Verilog? Is the question. Okay. Schematic hub, options. It's not it. It's... profile? No, not profile. Because I know you can export as Verilog. Sandbox. Is it schematic code? Oh, you can... Oh, hey! You can input projects that other people made. Yo. Four-bit register. Okay. 4-bit memory. QR code. That's sick. Well, I mean, we did a lot of engineering here. It might not have all been, what's it, the plant waterer, but we did a lot of engineering today. Better than LabVIEW. Because it has music. And a Discord server. And a Reddit. Play campaign sandbox. Oh! They're working on a level editor. If someone made an ARM processor. You know what? Let's take a look. Is it in schematic hub? Architectures. ARM and MEM. No. 'Yeah, somebody made a 32-bit microprocessor. Oh my god, somebody made documentation on their own computer architecture. That's actually sick. I think I'm gonna call it here. I need to add this game to the description whenever, but I'm definitely going to be playing a lot more of this game off stream. I want to get to that Turing complete computer, damn it. We're so close. I'm so close. When we get to immediate values, we'll have a complete computer. Holy shit. There's programming. Oh, there's even more. Wire spaghetti. Opcodes. More immediate values. Conditionals. Then we get into functions. Push and pop. Yeah. That we learn how to... Or, I remember hearing about that in my microcontrollers class. Honestly, this might teach me more about microcontrollers than that class ever did. Wow. If you're an engineer, this game is actually sick. Stack is the last thing. Yeah, the stack is right here. Designing your own processor. Jesus Christ. Yeah, this is the class I wish microcontrollers was. Kinda. I didn't want to go this low level. Maybe we could have gone without the CPU architecture stuff. But now that I know, it's like... The magnitude of what I'm making did not hit me until, like, right now, basically. You can design processors in this. What the hell? I mean, you can do this in any simulation software as well, but damn. I know there's a simulation software on, like, an online simulation software that does something like this, but it doesn't guide you through, like, each step of how to do the thing, you know? Just wow. Before I ramble on any further, I'm gonna end the stream. See y'all tomorrow, where I attempt to finish a YouTube poop within like 3 hours.